Salutations, mini mathematicians. You are rocking through Module 4. You're going to be learning your third method to solve a system of linear equations today, and that's called elimination method. So our purpose is to use elimination to solve a system. We're going to manipulate one or both the equations to add or subtract the system to cancel out or eliminate one variable. Then you're going to solve the equation because you're creating one equation with one variable, and then substitute this value into any equation to solve for the remaining variable. And of course, write your answer as an ordered pair. Because remember, this is still a system, which means the solution or solutions, if there is one, is the point or points of intersection if there is one. So one point of intersection, the lines have different slopes. No points of intersections, they have the same slope and different y-intercepts, or infinitely many points of intersection, meaning that they are indeed the same line. So let's get started. Problem number 1, we are using the picture to complete the following. So it says let x equal square and y equal circle, and write the system of equations. So I'm going to label these as 1 and 2. I'm going to label my x's as squares here, and I'm going to label my circles with a y and write my two equations. And the first equation in my system is x plus 2y equals 19. And my second equation is y minus x equals 11. So go ahead and take a moment and solve this system using the substitution method, which you're really good at by now. Okay, let's see how we did. Taking a look at solving the system, you should have gotten the answer -1, 10. So my work is that I decided to isolate y in the second equation because I just had to add x to both sides. When I substituted in, I got one equation with one variable, which you know how to solve. Tx is -1. Substitute that back in to get y and write your answer as an ordered pair. Well, we're going to solve this system another way. And since it's still the same two lines and they have one point of intersection now, hopefully they still have one point of intersection that's the same when we're done. So this system can be solved using the elimination method. So the elimination method is the process of eliminating one variable in the system equations using addition or subtraction and solving the system again. So what we're going to do is we're going to write out the steps to solve using substitution. So the first step is always going to be to line up your like terms and your equal sign. So step 1, so if we take a look at our equations, we're going to rewrite them. So equation 1, I'm going to leave as x plus 2y equals 19. So in a way, we're kind of writing them in standard form, but we don't have to worry about that x being positive or negative. And the second one, I'm going to just switch them so the negative x is going to be in front and the y will be second. So I have my like terms, x's lined up with x's, y's equals lined up with y's, equal signs lined up with equal sign, and constant terms lined up with constant terms. Perfect. The second step is to set this up for elimination. So what we're going to do is we're going to add or subtract the equations to eliminate one variable and create one equation with one unknown. So with only one variable. So taking a look at our system here, what I notice is that x and negative x are additive inverses or opposites. So because of that, if I added them together, they would disappear. So I'm going to do that. X plus 2y equals 19 and negative x plus y equals 11. So now that they are all lined up, what I'm going to show is I'm going to put parentheses around the entire second equation and show that I'm adding them. So we want to put an addition sign with a circle to show that's the operation we're doing to the two equations in the system. Parentheses around the bottom one to show that we're going to be adding all of the terms together, and just your little equals bar here. So from here, x minus x, well, there's a reason we added those together. It's so they cancel out. So blah, they're gone. And then you just continue and you have 2y plus 1y is 3y. And 19 plus 11 is 30. So here we created one equation with only one unknown, which is y. Okay, so step 3, what we're going to do here, step 3, is you're just going to solve for the variable. So let's do that. To get y by itself, I'm going to divide both sides by 3 to get y is equal to 10, which is part of our answer. Step 4 is going to be use one of the original equations and the solved for variable. So the one you already know, which in this case is y, to solve for the missing variable. So the only one you still need to know. So it doesn't matter which equation you use from the beginning. I like using one of the original ones just in case in rewriting them, maybe I made a silly mistake. So I'm going to label that I'm using equation 1, which is x plus 2y equals 19, just to keep things organized here. And then I know that y is 10. So showing all my work so I don't make a silly mistake. Subtracting 20 from both sides, x is equal to -1. And then we are not done yet. We still need to 5 write your answer as an ordered pair. X comma y, and optional is to verify. So your final answer here is -1, 10. Remember, by ordered pair, I just mean alphabetical order. So it could be A comma B, A comma W, W comma Z, alphabetical order. So part D says, did you get the same solution as when you solved for using substitution? Yes, of course we did. Yes, why? Well, we solved the same system that only has one solution, the point of intersection. Point of intersection. It's not going to change. Excellent. A lot of students find elimination to be more efficient than substitution. And again, you can use either method to solve a problem unless I am specifically asking you to use a specific method. So in this case, we are really focusing on elimination since it's a new method for us. So let's focus and practice. Okay, so 2 and 3. Directions say use elimination to solve the equations and show all your work. Write your solution as an ordered pair. Okay, so taking a look, what I'm going to do is I'm going to investigate my system first and see if I have additive inverses, meaning one's a positive number and the other is an equal negative number. So that when I add the system, the variables cancel out and I'm that much closer to solving my system. So here I notice my y's are additive inverses. So if I add my system, make sure you're putting parentheses around the entire second equation. If I add my system here, I notice my y's cancel out. Blah, they're gone. And I'm left with 3x plus 4x, which gets me 7x, is equal to 4 plus 10, which is 14. From here, I can just divide both sides by 7, and I get x to equal 2. So that's half the answer. To get the second half, I'm going to use equation 1. I'm going to say 3x minus 2y is equal to 4. I know x is 2, so 3 times 2 minus 2y is equal to 4. 6 minus 2y is equal to 4. Subtract 6 from both sides. Negative 2y is equal to negative 2, making y equal to 1. Putting that all together into my final answer here, 2, 1. Answer as an ordered pair and give it some flair. And here I can quickly verify into both my originals if I wanted to. Let's move on and take a look at number 3. So number 3, I notice I do not have any additive inverses. I don't even have any variables that are opposites. Noticing I do already have my variables lined up and my equal sign and my constant terms, so that's good. So from here, what I can do is I can subtract my system because I'm noticing that I have equal terms, x and x. So positive 1x and positive 1x. So if I subtracted, these x's are going to cancel out. Many mathematicians beware here. Subtracting a system often leads to more mistakes because distributing that negative through can lead to mistakes. So I want to show you something else. So thinking about the definition of subtraction, and use the definition of subtraction a lot last year, meaning if you had 2 minus 7, I could always rewrite that as 2 plus negative 7. Instead of subtracting a number, it's the same as adding the opposite. So both of these are equal to negative 5. So here, instead of subtracting this entire second equation, I can multiply the second equation by negative 1 and then add the opposite. Opposite means instead of positive x, it's negative x. Instead of positive 2y, it's negative 2y. Instead of positive 25, it's negative 25. I'm just going to leave the original top equation, equation 1 alone. So here, I'm a lot more comfortable adding systems. So x plus negative x gets you 0. Y plus negative 2y will get me negative y. 18 plus negative 25 would get me negative 7, which would get me y to equal 7. Again, you don't have to do that. It's just going to make your life a little bit easier. The reason we can multiply both sides of this equation by negative 1 is because that multiplicative equality property, meaning if we have two sides of an equation, you multiply by the same amount on both sides, the equation still holds true. So we're just manipulating this. So taking a look here, we could have subtracted x minus x is 0, y minus 2y. Remember, we have to distribute this negative to every single one of these. Y minus 2y is negative y, and 18 minus 25 is negative 7. So again, we get y equals 7. So just want you to be aware, instead of subtracting a system, you can always add the opposite. And that's because of the definition of subtraction, which tells you instead of subtracting, you can always add the opposite. And use that a lot last year, especially when you were doing tile models. Okay, but we still need to find the rest of the system. So I'm going to use equation 1, x plus y equals 18, solve the solution. Here we know that y is 7, subtract 7 from both sides, and x is 11. So I can write my answer as an ordered pair and give it some flair. Nice job. Okay, well, let's take a look at number 4. Number 4, Aaron made a mistake. I'd like you to finish number 4 and 5. Go ahead and look at number 4 and 5, and we will go over that in just a second. Okay, so number 4. So looking at Aaron's work, Aaron did a really nice job, but she made a mistake here. So Aaron's mistake is that when subtracting the second equation, 3x plus 6y equals 5 from the first equation, 3x plus 4y equals 10, she did not subtract the y terms or the constant terms. So she needs to make sure she distributes that's negative. So to solve the system correctly, remember we can use subtraction. Should have circled that. Or we can add the opposite by multiplying the second equation by -1 to add them together. Either way, you're going to get the y value of -5/2 and the x value of 20/3. So 20/3 comma -5/2. So what could Erin do? How could she manipulate 3x plus 6y equals 5 to avoid using subtraction? Like I said above, definition of subtraction is subtracting is adding the opposite, which means what we can do is multiply that second equation by -1 and then add the system to eliminate the x variable. It's really important when we're just explaining this is which variable are we going to be eliminating. Cool, nice work. Okay, so moving on. Number 6 says solve the system of equations by elimination. So taking a look at this, you have your options here where we could solve this by subtracting the system because we have two y's that are the same amount, or we can multiply the second equation by -1 and then add the system. So go ahead, take a moment, pause the video and finish number 6, and we'll check our answer in just a second. Okay, let's check our answer. So the correct answer is 4, 11. I decided to multiply the second equation by -1 and add the system just to avoid making silly mistakes with negatives. The y's eliminated. I got x to be 4, and then to solve for y, I substituted into equation 1. I could have picked equation 2, but I picked equation 1. I wrote my answer as an ordered pair. And remember, you can always verify by substituting x and y into both of the equations, Okay, so let's take a look at number 7. Number 7 says complete the following for the given system of equations. So I'm going to label this 1 and 2 so we can discuss the solving process. Part A says explain in words what operation, and they mean addition, subtraction, multiplication, division, must be completed in order to eliminate the x variable. So taking a look here, equation 1 and equation 2, notice none of the variables are additive inverses, just opposites of each other, and none of them are equal. So we can't just add or subtract the system to eliminate a variable, but we can multiply one or both of the equations to create additive inverses. So we can add the system and eliminate. So to talk about in words, remember this problem wants us to eliminate x. So notice I have a 4x and a -2x, which is great because they're already opposite signs, which tells me I don't have to multiply by a negative. Whew, avoid working with negatives whenever possible. So here, let's write to eliminate the x variable, multiply, and I want them to be additive inverses. So since this is 4x and this is -2x, I'm going to multiply the second equation by 2. The second equation by 2 and add the system. And it's really important, again, to say if you're adding or subtracting the system and which variable you're eliminating. Okay, part B says solve the system equations by eliminating the x variable. So following what we said up here. So I'm going to write equation 1, 4x plus y is equal to 7. Make sure to write them down correctly. And equation 2, -2x minus 3y is equal to -1. And from here, we said we're going to multiply the second equation by 2. So sometimes what I like to do is call this like 2 star, so I know that it's the same as 2, but it's just multiplied, so it's a multiple of it. So here I would get -4x minus 6y is equal to -2. And I'm just going to bring over my top equation. 4x plus y is equal to 7. I'm going to show that I'm adding the entire second equation, putting my addition sign in a circle. 4x plus negative 4x by x, right? It's gone, gone. And then y plus negative 6y gets me negative 5y. And negative 7 plus negative 2 gets me 5. 7 minus 2 is 5. Divide both sides by negative 5, and I get y to be negative 1. Remember, we're not done yet. Our answer is an ordered pair or pairs if there is one. Since I already found half my ordered pair, I know there's 1 point of intersection here. So I'm going to use equation 1, which is 4x plus y is equal to 7, and substitute in my y value of negative 1 to equal 7, and solve for x. So I'm going to add 1 to both sides and get 4x is equal to 8, divide by 4, and x is equal to 2. Final step is to write your answer as an ordered pair, x comma y, alphabetical order, and give it some flair. What I want to remember is that we could eliminate the y variable first. So we're going to solve the same system, hoping we get the same answer if we do all of our steps correctly. It says, explain in words what operation must be completed in order to eliminate the y variable. So I'm just going to write my equations down here because I'm going to need them anyways. So 4x plus y is equal to 7, and negative 2x minus 3y equals negative 1. So I could solve this system by eliminating the y variable first. It's going to be just as efficient because I notice my y's, one is negative, one is positive, so they're already opposites. I don't have to multiply by a negative, which is great. And they are multiples. 1 and 3 are multiples of each other. So using words to eliminate y, the y variable, y, we can just say y, multiply. So let's think about this. I would need to multiply this first equation by just 3, by 3. So to eliminate y, multiply the first equation, you can also call it like equation 1, by 3, and add the system. Perfect. So we're going to do that. When we do that, we're going to end up with 12x plus 3y is equal to 21. And we're just going to bring over that second equation, negative 2x minus 3y equals negative 1, making sure those like terms are lined up, showing we're adding the system. Here's our addition problem. So 12x plus negative 2x is going to get me 10x. 3y minus 3y, y is gone, by y, and then 21 minus 1 gets me 20. Divide both sides by 10 to get x is equal to 2. From here, that's half my answer. Pick either equation to substitute in x to solve for y. I'm going to use equation 1. 4x plus y is equal to 7. 4 times 2 plus y is equal to 7. 8 plus y is equal to 7, and y is equal to negative 1. Almost done. All you have to do is write your answer as an ordered pair and give it some flair. Okay, and look, notice we got the same answer. So after examining your solutions for part B and part D, what can you conclude about solving the systems by elimination? So remember, to get our answer for the first one, we eliminated the x variable, and the second one we eliminated the y variable. So we can say you can eliminate x or y first to solve the system. Look for what is easier, but remember, we don't use the E word, easier, because That's all in comparison of what's easy. So look for what is most efficient. Most efficient. Work smart, not hard. You can make these problems real difficult on yourself or pretty darn easy. Okay, so last page is we are just practicing 8 through 15. We're going to be solving the system using elimination. And as we're doing that, we want to be thinking about what's going to be most efficient. So we always want to double check, are our like terms lined up? Are our equal sign lined up? Is our constant term lined up? Is there any simplifying you can do? So I'm going to help you with the evens, and then you are going to do the odds. So taking a look, the first system number 8. First thing I'm going to do is I'm going to label these as 1 and 2. And from here, I'm going to notice that my x's, y's, equal sign, constant terms, they're lined up. I don't have any opposites. I don't have one being positive, one being negative. I don't have any additive inverses. So I could eliminate x by multiplying equation 1 by -5, or I could eliminate y by multiplying equation 2 by -2 and adding the system. And since -2 is a smaller number, that's the one I'm going to pick. So I'm going to choose to eliminate y. So here I'm going to have x plus 2y is equal to 15. Multiplying everything by -2, I'm going to have -10x minus 2y is equal to -42. From here, remember, I'm going to put parentheses around my entire second equation and show that I'm adding my system. Y plus -2y, they gone. X plus -10x is -9x. 15 minus 42 is -27. Divide both sides by -9, and x is equal to 3. From here, I still need to solve for y. I can use equation 1 or equation 2. I think 1 looks a little more efficient because it's smaller numbers. So x plus 2y is equal to 15. X is 3. Subtract 3 from both sides. 2y is equal to 12. Divide by 2 on both sides. Y is equal to 6. Final step, that's right. Write your answer as an ordered pair. Give it some flair. And of course, if it was an assessment, you could always verify in both equations to make sure you have a true statement. And by verify, I mean substitute x for 3 and y for 6 in both equations to make sure you get a true statement. Awesome. Remember, if you need more space, you can always write these on a separate piece of paper. Okay, taking a look at number 10, first thing I need to do is simplify these and line up our like terms. So taking a look at equation 1, show some work over here. I'm going to distribute that 3, and I'll get 3b minus 9 minus 2c is equal to 0. From here, I'm going to put my b's and then my c's. So I'm going to add 9 to both sides, and I'll get 3b minus 2c is equal to 9. And my second equation, equation 2, when I distribute that 2, I would get 2b minus 2c is equal to -b minus 3. So I'm going to add b to both sides to get my b's on one side, my c's on one side, and my constant terms on another. And I would get 3b minus 2c is equal to -3. So taking a look at my two equations, what I notice I have, 3b minus 2c is equal to 9, and 3b minus 2c is equal to -3. I could multiply my second equation by -1 so I can add my system. So I'm going to do that. Multiply this by -1, and that's going to be -3b plus 2c equals +3. And then what I'm going to do is I'm going to show adding my system. Awesome. So 3b minus 3b is 0. It's gone. 2c plus -2c plus 2c, it's gone. So I have 0 on this side. And 9 plus 3 is 12. Gee golly, our variables canceled out and we were left with a false statement. What does that tell you? What does that tell you about any equation where the variables cancel out and you're left with a false statement? That tells you, yes, indeed, this is no solution. What does that mean? Lines are parallel, no point of intersection. So no solution is your answer, so I'm just going to circle that. Awesome. Let's move on to number 12. And remember, if you get no solution or infinitely many, you cannot verify that. So just make sure to go through your work and make sure it's adding up. Okay, number 12. Taking a look at number 12, I'm noticing I have 11x and 9x. Both of those are prime numbers. I don't want to multiply to make them additive inverses to add the system and eliminate x. But y, I'm pretty happy about that 5 and 15. 15 is a multiple of 5. So I could multiply my first equation by 3 and subtract the system, but I want to add, so I'm going to multiply the top equation by -3. So from here, I'm going to have -33x plus 15y is equal to -240. And equation 2, I'm just going to have 9x minus 15y is equal to 120. Remember, I said that I was going to be adding the system here, putting parentheses around my entire second equation to add them up. -33x plus 9x gets me -24x. 15y plus -15y by y. -240 plus 120 gets me -120. Divide both sides by -24, and x is equal to 5. Which is awesome. Now I just have to solve for y. I could use either equation. I think I'm going to use my second one just because it seems like a little bit nicer numbers to work with. So 9x, oh, this is my second one, 9x minus 15y is equal to 120. 9 times 5 minus 15y is equal to 120. 9 times 5 is 45, minus 15y is equal to 120. Subtract 45 from both sides. -15y is equal to 75. Divide both sides by -15. Y is equal to -5. Final step, that's right. Write your answer as an ordered pair. Give it some flair. If it was an assessment, make sure you are substituting back in to make sure you get a true statement for both. Okay, 14. Remember, step 1 when we are solving these systems is to line up your like terms and your equal sign. So taking a look at 14, gee golly, you have variables all over the place. So let's clean this up. So I'm going to write this as 1 and 2 just to keep my work nice and organized. Taking a look at equation number 1, I'm going to subtract f from both sides. So I'm going to have 5c, I'll just write it up here, minus 4f is equal to 31. And equation 2, I'm just going to subtract 2f from both sides and then swap the sides. So minus 2f is negative 4f, right? -2, -2, yeah. -4f, and I still have this -8c. This is equation 2, and this is equal to -8. From here, I notice that I have -4f and -4f, so I could subtract my system, but with all these negatives, I'm pretty sure I'd make a mistake. So I'm going to use that definition of subtraction to multiply equation 2 by -1 and just say 8c plus 4f is equal to 8, and bring over the first equation, 5c minus 4f is equal to 31. Show that I am adding that entire second equation. 5c plus 8c is 13c, -4f plus 4f by f. 31 plus 8 is 39. Divide both sides by 13, and c is equal to 3. From here, I still need to solve for f. You could use one of your manipulated equations. I really like going back to my original just in case I'm making a really silly mistake. So I'm going to use equation 1 and say 5c minus 3f is equal to 31 plus f. C is 3, so 5 times 3 minus 3f equals 31 plus f. I'm going to subtract f from both sides and multiply 5 times 3. 15 minus 4f is equal to 31. Subtract 15 from both sides. Negative 4f is equal to 16. Divide both sides by negative 4, and f is equal to negative 4. And final step, write your answer as an ordered pair. Sometimes I like to write them in alphabetical order right below so I don't make a silly mistake when it's not X or Y or A, B. Sometimes I have to sing the alphabet really quick in my head, A, B, C, D, F, G, H, I, J, K, L, M, N, P, right? And that's fine. Do what you need to do to make sure you're getting the answer right. Make sure to give your answer some flair so it stands out. Excellent work. Okay, so you're going to work on 9 through 15. Working on 9 through 15, pause the video and we're going to go over them as soon as you're ready. Okay, let's see how we did. Number 9, we should have gotten the answer of 4, 1. And I'm going to show you the way I did the problem. Of course, maybe you did the problem differently, which is totally fine as long as you got the same answer because these systems only have one solution, no solution, or infinitely many solutions. So looking at equation 1 and 2, I noticed I don't have additive inverses and I also do not have terms that are the same. So I decided to eliminate y because 3 and 4, I saw I can make them both into 12 and negative 12. You could have eliminated x just as easily because we could make them negative 6 and 6x. From here, you solve to get x is 4 and y is 1, 4, 1. Okay, taking a look at 11. Taking a look at number 11, I saw I have x's, positive x's, and negative y's. My x's, y's, equal signs, constant terms already lined up, so that's good. I personally decided to eliminate y. You could have eliminated x's to make them positive and negative 15. I decided to eliminate the y's. So here I did need to multiply both of my equations again to create terms that are opposite here. So sometimes you have to only multiply one equation, sometimes you have to multiply both. So here we have 15x minus 10y equals 10 and negative 10x plus 10y equals negative 20. A y is eliminated, x to be negative 2. Substitute that in to get y is negative 4 and writing your answer as an ordered pair, negative 2, negative 4. Taking a look at 13, 13 got a little bit busy because the first thing you need to make sure you're doing is line up your like terms. So here you have your y's on both sides and x's. So the first thing I did when I got my like terms on both sides, I got 6y minus 5x equals 1 and negative 4y minus 2x equals negative 4. From here, it's going to be most efficient to eliminate my y's because I have a negative y and a positive y, and I can avoid multiplying by a negative. So to do this, I'm going to make them each 12y, negative 12y. So I multiply equation 1 by 2 and equation 2 by 3. From here, the y's eliminate, and I can solve for x to get 5/8. Next, I need to still solve for y. I chose equation 1. Notice from here, when I had negative 25/8 and I needed to add 25/8 to both sides, I decided to think about 1 as 8/8. So when you are adding 25 and 8, you get 33/8. From here, when you have 6y equals a fraction, you want to divide both sides by 6, but remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So you can think also about multiplying both sides by 1/6 to help you get your final y value of 11 over 16, make sure you simplify to write your final answer as 5/8, 11/16. Again, sorry that was a little squished in there. Number 15, here I decided to take a look. I had A, B, and the A and B were on both sides here. So I rewrote equation 2 to be A minus 3B is equal to -4. And from here, I notice that if I multiply the top equation by -2, I get -A plus 3B equals -4, and I get a true statement. So your true statement might be another number equaling the same number, but it might not be 0 minus equals 0. Maybe you got 4 equals 4 or -2 equals 2, something. I end up with 0 equals 0, and this is a true statement. And that means there's infinitely many solutions because these lines are indeed the same line that intersect everywhere. Remember, if your variables cancel out and you get a true statement, a number equals the same number, that means there's infinitely many solutions. Awesome job. Great work, mini mathematicians. That was a lot. Keep it up, and I will see you next time.